Hi, welcome to the Shiko Math Lab Fun Probability Problems Solving section. And today we're going to do a simple proof about the DeMorgan law. You know, when we first start the probability class, we always start with events, sample space, and then one of the first law we learn is DeMorgan. All right. So today, let's take a look. This law is very intuitively true. So let's see how do we use the formal way to prove these ones here. All right. Okay. So let's go ahead get started here. Okay. So the DeMorgan law, we try to prove here is this one is A intersect B, two events, and B. Then the complement of these two events will be the A complement union B complement here. I always, told my students the reason why I said intuitively makes sense is kind of like in the algebra. So for example, if you put like a negative, like if I have a 3 minus 5 here, we all know the distributive property is kind of like you change to this one become negative 3, then these numbers here, the negative become positive, right? So the positive is here, then you put the negative 5 here, so it's a positive. So it will be negative 3 plus 5. So in here, it's kind of like this is like you can treat as the complement. So you put each one in front of it, and then this one's here, you treat like the intersection, and you change back to the unions here. So it's kind of like it intuitively makes sense. Okay, so now let's take a look. How do I use the mathematical proof to show this simple laws here. Okay, so let's start here. So we say let W be an element. Okay, so let be an element belong to the A intersect B complement. A intersect B complement here. Okay, so that means we can write here, we'll say that W belong to A intersect B complement. So that means if the complement, that means W is not going to belong to A intersect B's, right? So if we use a simple Venn diagram, we know this is A, this is B here, right? So then this little green area, this is A intersect B, but I'm in the A intersect B, the complement. That means W is not including in this green intersection problems here, the regions here. All right, so now in here, because W is not inside here, so W could be where? Okay, so that means W cannot, maybe it's not in A, all right? Or, okay, so here we say or W not in B. Okay, so in here, we can take a look see here, right? So here, let's see here, because W not belong to A intersect B. So one place it should, W could be here, or W could be here, or W could be here, right? So when the W in here, in these regions here, so that means W definitely is not in the B's, right? So the same thing is here. If W is in here, that means W is not in the A, because if W in here and here is not in the A, then a while ago if W is in here and here is not in the B. So, but I don't know which one. So that's why this will become or, right? So it's W not belong to A or W not belong to B. Then because W is not in A, all right, because W is not in A, that means W must belong to, okay, must belong to A complement, correct? And W not to B, that means W must belong to B complement. And then my over still true here. Okay, so because we know in the statistic and is intersection or is union, so that's why we come up the, so because W belong to A complement or W belong to B complement here, so we will say W belong to A complement union B complement, right? So from here to here is what? This is the definition of union, okay? And this one's here, so this one's in here because from here to here, because I know A intersect B complement and A intersect B, they are mutually exclusive. Mutually exclusive, right? Okay, and then that's why we said we can say because it's not here, it's belong to A intersect B, so there's not going to be the intersect B is here. All right, so this proof is pretty simple, right? So I know if the W in the A intersect B complement, so from here, right? So from here, then we finally proved it's here, right? So the if the W is mutually exclusive, and this one's here by using the definition of intersection, right? So let's see it's this part here, right? So this part is the definition of the intersections. All right, so that means W belong to that. All right, that's it. So like I said, this is a pretty simple but a very basic proofs here, and it's intuitively true, but now we know how to prove it. All right, okay, nice talk to you. You have a nice day, and let's talk to you. Let's talk about the next interesting problem in the next video. All right, bye.